Hello, welcome back. Myself Jai Tandil, working as assistant professor at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we will going to learn about the armature, as we discussed in lecture number 3.1. As I told you that we already started new chapter of a DC machine, right? So construction of that DC machine and working principle, as well as EMF equations of the DC machine, that we already discussed. Now during a explanation of the construction of the DC motor, I told you that the functions of the commutator that will be different for the different machine, right? In case of machine are different, generator are different, in case of motor are different. So today we are discuss a detailed construction of commutator, armature, right, and some important theory of derivations of the torque equations, right, construction of some commutator and its different function, right. So let's begin. First of all, and some element and some important terms like pole pitch, back pitch, what is a front pitch, right, we already discuss roughly on Google Meet. So now we start with the armature coil. So as you see in the figure, this is armature and armature slots having armature winding. So it is at a input side connected with some commutator which is already fitted on shaft. So other conductors, other polarity conductors connected on positive side, and other side it is connected with the negative terminal, and whole thing that is connected with the not physically connected with the brushes, we can say. So when the rotor armature is rotated, so positive and negative sign of armature conductors are to be such a manner that we are getting some we are giving some power to the armature, right. So actually brushes and slip ring arrangements are provided for machines for that purpose, because we need to current carrying conductor, right, that's why. So now what is a pole pitch? So as a name of pole, right, we have a stator pole, a field pole, and some poles having some windings, right. So definition wise, it's a peripheral distance between the center of the two adjacent pole. We have a, as we discussed in construction, we at that time we have a 4 pole, right. So adjacent distance between the pole in DC machines, it is called as a pole pitch actually. So this distance is measured in terms of armature slots or armature conductor that comes between two adjacent pole center. So now the pole pitch is equals to the total number of armature slots divided by total number of poles. So pole pitch we need to find, suppose pole pitch, then how we calculate it? Pole pitch, total number of armature slots, armature na jetla slots hoy te divided by total number of poles, slots per pole. Simple, we can say that is called as a pole pitch. For better understand, I consider one example. You can see over here, if there are 96 slots, I am talking about these slots, okay, armature slots, and we have a as construction 4 pole machine. So what is a pole pitch? So 96 divided by 4, that is equal to 24. So we can say our pole pitch of the DC machine would be 24 pole. For example, I repeated, if I have a 96 slots on the armature peripheral and the 4 pole machine, 4 pole that is regarding to the field main pole, right, and 96 slots that is a armature pole, means rotor pole. So number of armature slots that comes between the two adjacent pole center would be 96 by 4, means 24. So we can say my machine having a 24 pole pitch. Now the pole pitch is equal to the total number of armature slots divided by total number of pole. We alternatingly refer as the armature slots per pole. It is called as armature. So here are two figure, you can see or see over here, phase A, phase B, and three phase system, right. So my 3 current that will be likewise what we will discuss later how this form that will be occurs, right. It is 120 parts of that, right. We will discuss later that, but today's topic is that main thing is some term like pole pitch, front pitch, back pitch likewise. So pole pitch means what? Total number of armature slots divided by total number of pole, that is called as that would be your pole pitch. Now we further go to the coil span. Coil span is also called as a coil pitch, right. So coil span or pitch we can say, which is defined as a peripheral distance between two side of the coil, or it is measured in terms of number of armature slots between them, that is called as a coil span. Coil span આ બે વચ્ચેનું જે ડિસ્ટન્સ દેખાય, એક કોઇલ ચાલુ થાય ત્યાંથી પૂરી થાય અને નીચે આવે તો આ બે વચ્ચેનું ડિસ્ટન્સ પેરેલલ પાથનું, that is called as a coil sides, right. આ coil side 1, coil sides 2, તો that is indicate a span, આને span કહેવાય, right. આની અંદર નંબર ઓફ એક સાઈડના બહુ બધા પોઝિટિવ કંડક્ટર્સ હોય, હવે નેગેટિવ કંડક્ટર હોય, તો બે વચ્ચેનું ડિસ્ટન્સ that is called as a coil span. I repeat that. Coil span or coil pitch is defined as a peripheral distance between the side, distance between the side of the coil, which is measured in terms of number of armature slots between that. That means that after placing a one side of coil particular slot, after how many congested slots other sides of the same coil is placed on the armature, which is known as coil span. So simply it is defined by over here, coil side 1, coil side 2, between that distance is coil span or coil pitch. Now here I just give you the example of wave winding or the winding, right. It is suppose lap winding, then there is overlapping, that we will discuss in lecture number, we will discuss on lecture I think 4, right. So here are the N1. My coil is started from here, you can see over here, it is ended over here, it is dotted line. So first it is started with the ended, between that what will be the distance, that is called as a YB, it is called as a back pitch, right. So first definition wise, a coil advanced on the back of the armature, this advancement is measured in terms of armature conductor, is called as a back pitch. You can see starting of the first coil and ending of the another first coil, that is distance, that is called as a back pitch. It is equal to the number of difference of the conductor which is connected to the given segment of the commutator, right. So these are the commutator over here, right. These are the armature winding. Lap and wave winding are the types of armature winding. So I am talking about armature winding. Okay, so in which the first slide starting and another slide ending, which between that whatever the distance, that is called as a back pitch. Now front pitch, alternatively you can see over here front pitch, first slide end and second slide starting, you can see over here, second slide starting, second winding starting, first winding end, whatever the distance between that, that is called as a front pitch. So alternatively we define the front pitch as a distance between second conductor of the next coil which is connected to the front, example take commutator end of the armature, it is called as the commutator end, whatever the commutator end between that, here is the commutator end, whatever the two winding connection, it may be a first winding end and second winding starting, that distance is called as a front pitch. Third, that is a resultant pitch. Now as we know that starting of the first and starting of the another, that is between that, that is called as a resultant pitch. Why? You can see over here. So it is a distance between the beginning of the one coil and beginning of the next coil to which it concern, it is called as a resultant pitch or commutator pitch. Commutator pitch is also same. The commutator pitch is defined as a distance between two commutator segment in which the two ends of the same armature coil are connected. We measure the commutator pitch in terms of commutator bar or a segment, right. Now commutator. So we already discussed about most important thing, that is a coil pitch. Before that, pole pitch. What is pole pitch? Slots per pole, armature slot per pole, that is called as a pole pitch. Coil span, to adjacent distance between the peripheral at the end of that, that is called as a coil span or coil pitch. Back pitch, starting of first, ending of first, between that back pitch. Front pitch, at the commutator segment, both one coil is ending and another coil is starting, that is called distance between that, front pitch. Resultant pitch, Y pitch, that is the starting of both parallel path of the both windings, that is called as a resultant pitch, commutator pitch, right. Now what is a commutator? So commutator is a electrically rotating switch, we can say, which is continuously connected with the brushes, right. In a particular type of generator as a motor, so it is mainly used for supply the winding only, where in case of generator it will be collect the current from the armature. So it comprises of the cylinder with the numerous metal contact segment lying on the revolving armature of the machine. The brushes or electric contact are made with the carbon press materials next to the commutator. So designing sliding contacts by the consecutive segments of the commutator while it revolving, while it rotating, we can say. The armature windings are aligned to the segments of the commutator. Last point, the applications of the commutator, which is include the DC machines like a DC generator and a numerous DC motor, as well as universal motor too. So in the DC motor, the commutator which is provided the electric current to the winding. So by changing the direction of the current with the revolving winding, every half turns the torque will be produced. So construction, so you can see over here commutator is like that. It having a slots too, because it directly connected with the armature. Armature having slots, commutator having slots. Then and then all the windings of commutator armature winding, that will be connected through. So you can see over here commutator segments are this. These are the outer line, that is commutator segment which is connected with this C, and commutator segment are rotated. Okay, brushes are fixed. Okay, this is a direct current which may be collect or may be drawn. In case of generator, there is alternating current is produced over here, but it will be taken by the in form of DC by the commutator. So commutator function in the DC generator. Okay, now construction wise in DC motor, the armature current is causes to set the magnetic field to use the rotating force. Otherwise, the torque over the winding for making it revolving. So in a DC generator, machine torque can be applied in the directions to the shaft of the machines to maintain the armature winding motions via stationary winding field. So the stimulating current within the winding on those two cases, sometime commutator will be reverse the direction of current flow through the winding. So sometime within a external to the machines maintaining the directions of that. Now function of commutator in case of motor is different, generator is different. Commutator in case of DC motor is reverse the flow of current with the accessible for the DC source at the exact point, while the armature coil is crossing the magnetic unbiased axis. So this is essential to keep the unidirectional torque. Therefore the commutator will be change the DC current into the alternating current. So function of commutator in case of motor, converting purpose. In case of generator, the commutator in case of DC generator indicates the EMF within the armature coil will change the nature. Consequently, the flow of current in the armature will be also changed. So this current will be reversed by the commutator at the exact point. So with the armature coil is crossing the magnetic unbiased axis, so the load will be externally to the generator, will unidirectional current, otherwise the DC current. Now derivation of torque, that is another important theory. So we already talking about the important terms like coil span, back pitch, front pitch, commutator pitch, resultant pitch, right? Some functions of the commutator. Now finally last theory, that is derivation of the torque equation. So you can see I already put some resistance with series with the armature. So by varying the resistance I can change the torque. So load torque, first of all load torque of the machine, that will be different according to the applications. right? As I told you in previous, conveyor belt having a does not know at a time which product will be run, or which kind of load torque that will be applied over there. So torque equations need to be found where if we know the basic terms of the machines, then we can easily find a torque equation. So final torque equation, that is always in case of DC, that is torque is proportional to the flux 5 into I. This equation may be vary according to the series or shunt motor, right? Series motor in case of flux is proportional to current, so torque is proportional to I square. That's why series motor can be used for high torque application, right? So yeah, here is the E, that is a some voltage, EB that is a generated voltage, IA that is a current which is flow for the armature, right? So E that is a supply voltage, EB that is back EMF, IA, RA are the resistance and current respectively. So in case of motor, what we write, V is equal to EB plus IR, equation number 1. Now I put what I do, put I current both side multiplying. Over here I multiplying IA both sides. So what over here, IE into IA, EB into IA, IA square into RA, right, which is over here. So we know that I square R are the losses, right? So power, this is the all, this is a equation of power. Power P is equal to VI, power P is equal to VI, power P is equal to I square into R. So I square into R, that is a power loss. So we can say mechanical power is equal to जहाँ back EMF generate થાય તે, so EB into IA. So power PM is equal to torque into angular speed, right? Where the omega is the speed in radian per second, which is put in equation through the equation 4 and 5. 4 and 5 we get these equations, right? Now EB is equal to P phi and Z by divided by 16 to A. This is a back EMF equation that we know very well. P is equal to number of pole flux, Z is equal to number of conductor, A is equal to number of parallel path, and is a speed. So angular speed is equal to 2 pi n by 16, which is simply put over here with we can say equation 6 and 7 in equation 4. So 6 and 7 equation number 4, we have a torque equation, we have a omega. So if I put that equation to that, so we can find TG is equal to PZ 5 into IA into 2 pi A. Remember that mechanical torque is equal to always generated torque minus some losses. So we can say the torque equation of the DC motor, it can be further simplified. TG is equal to, see over here in this equation, some P that is fixed after manufacturing, Z that will be fixed, 2 pi A that will be fixed, IA that may be vary. So only the remaining term, that is flux phi into IA. In this equation only remaining term flux phi into IA, otherwise all are constant after the manufacturing. So we can write T is equal to K phi into I, or we can say T proportional to flux phi into I, when K constant is equal to Pz by 2 pi into A. We can consider the constant. Why? Because it does not change after manufacturing. Thank you.